Welcome back. This is Concept Development Practice page 25-2 on shockwaves. If you make a sound, you are going to interrupt the air around wherever you are, and you are going to send out sound waves away from that sound. If that sound is moving, you're going to send out concentric circles as it's going. So it's almost like a cone of sound that you're going to be emitting. Real close as it's making the sound, and then as it disturbs the air around the sound, you're going to get it to go farther and farther away in a sphere, in a three-dimensional round shape. If the plane is traveling faster than the sound, you get something interesting called shockwaves, and so we're going to be looking at these in terms of sound. So they've got a few pictures here. This is just an idea of there's a plane that's traveling there along that dotted line, and it is disturbing the air. So you have this wedge shape that you can see here that's disturbing the air. If you were to draw a circle at any place along that dotted line so that you have a radius and the radius goes all the way around, so it's a perfect circle, you're going to see that the plane is always going to be in front of that circle. The reason the plane is in front is because as the plane passed, it made a sound. The engine or whatever made a sound. As it made a sound, then you have concentric circles of air disturbance that's going around, you're making that sound. In the meantime, the plane is actually traveling ahead. So if you end up with the plane going slower than the speed of sound, then sound is going to travel faster than the airplane. So as it's going around, the sound would travel far out here and the airplane would be inside the circle. If the airplane is traveling faster than the speed of sound, then the circle is always going to be behind the airplane. Okay, so by doing a simple graph like this, you can actually figure out how fast a plane is moving if you were to know what the speeds of the disturbed air is. So all of these are at different times, but all of them have the same basic geometry. You have the plane is the same proportion ahead of the circle in all cases. So this would be at a one time, this is at a later time, this is at a later time, but you're going to see that the plane is at a circle distance about the same. So let's look at this. I'm going to read this to you because it's actually important. The cone-shaped shock wave produced by a supersonic aircraft is actually the result of overlapping spherical waves of sound. So you're going to end up with a situation where it's going to go out like this, and it's going to get bigger as it goes out, and it's going to be kind of a cone-shaped wedge. Okay. Sketches A, B, C, D, and E to the left are animated growth of only one of many spherical wave sounds. So they've just taken one out of it so that you can see the difference. Sketch B shows that the growth of the circle position at a later time, and then C, D, and E. Note that the circle grows and the aircraft moves further to the right. Note also that the aircraft is moving faster than the sound wave. Okay, so if the aircraft is outside of that circle, it's going to be faster than the sound wave is. Careful examination will reveal just how fast the aircraft is moving compared to the sound, and this is what we're going to do today. We want to know what's the proportion, how much further is it, say, what's the radius of this circle? Now what is this radius? Or, if you want to think of it more simply, what's the radius of the circle from the beginning of the sound to the end of the sound compared to the beginning of the plane to the end of the plane? So you're comparing this distance to this distance. You're making a comparison. And then in that ratio, you'll know if twice as big, if this is 4 and this is 2, you'll know it's twice the speed of sound or 3 times speed of sound or whatever. Okay, so let's look at some of the questions. Inspect sketches B and D. Has the aircraft traveled twice as far as this in the same time in these positions? Previous paragraph said E shows, okay, they've got here E, that the distance here from origin to A, this distance here, is actually twice the distance of this. So 0 to B is twice the distance from 0 to A, And that indicates that the plane is going twice the speed of sound. So your first question is look at B and D. Okay, so B and D, which are simply earlier times, are they also going twice the sound? So I am going to put my little ruler on top of this iPad and see what we got. Okay, so let's do B. Okay, so got 3 and then 6. Yeah, it's going twice the speed. Now what about this? We've got 7, 14. Yes, they're twice as much. So the answer would be yes. This is going to be, it's twice the distance, so it's twice the ratio, so it's twice the speed. Okay? Now this is a little bit of an interesting question. For greater speeds, is the angle going to be narrower or wider? Okay? Let me give you an example. If I do a very wide triangle like this, okay, and I have a circle that's here that fits in that, can you see that this is not going to be twice? From here to here is not twice from here to here. So the wider the angle, the slower the plane is going to go. The narrower the angle, so if I were to do a very narrow angle like this, and here's the circle that would fit in here, do you see this is going much farther? So this would be even more than twice, even more than 3 times. It would be almost 4 times faster. So the faster the speed, the narrower that the shock wave would be. So we're going to have to use a ruler to estimate these two. So let's put a ruler on top of this. Okay. So we have a first one is going to be from the center of the circle to the edge of the circle. This is the speed of sound. So if I lay a ruler here, I get 15 millimeters. Okay. Now we're going to measure from the origin of the sound to the edge of the plane, where the plane happens to be. And I roll that out, I get 23 millimeters. Okay. All right, so I'm going to take the plane speed of 23. I'm going to divide it by the sound speed of 15. And 23 divided by 15 is 1.5. This plane is traveling 1.5 times the speed of sound. Okay, so let's do it again. This one now is, if I measure that out, 16 millimeters. Okay, from the origin to the plane is 48 millimeters. Okay, so I'm going to take the plane first. So I have 48 divided by 16. Okay, that goes in perfectly. It goes in 3 times. So plane B is traveling at 3 times the speed of sound. So what we're doing is we're using, you could do it either way. You could use the aircraft's speed that you know by its speedometer and find out how big that the sound wave is in at any time. Or if you were to know the sound wave, if you were to know the size of the wave, you would then be able to determine how fast that it is going. And if you know how far, say, a plane is above the ground and how long it took for you to hear the boom, then you could also estimate, just by listening, you could estimate the speed of an airplane that's passing over your head. So it's pretty cool. Okay, let's continue. Now you're going to have to do a couple on your own. Okay, they're going to ask you to draw a circle. I assume it can be anywhere. Okay, so I'm going to try my best. I'm going to do a circle. Not very good circle. Okay, not really perfect circle. But this is about 1 radius. If that's the speed of sound, okay, from the time that the airplane passed that point, then 1 more radius would be here, 2, 3, 4, 5. Do you see what I would guess? Now that was kind of crude, but I would guess about 5 times the speed of sound. All right, now they're going to do even a harder one. They're going to ask you, now I'm going to be looking, do not just throw something together, I'm not going to give you full points. You have to do at least as bad a job as I can. All right, so I'm going to make a wedge, right? Let's make a dotted line so that I know where to put the circle. Try to make that in the half. Now put a circle in such a place, now it's what it says, 4 times. Okay. Don't know. Let's go backwards. Let's say here's 4. And there's 3, 2. There's 3. There's 4. So this is the center of the circle. There's the average. Okay. Really bad job. Can you kind of see? Here's the center of the circle. This is 1 radius, 2 radius, 3 radius, 4 radius. So the plane is going 4 times the speed of sound. Okay? Great job.